Alright, our work so far with quadratics has been dealing mostly with binomials, so when you have two different terms. And that's when you wanted to look for a GCF to help you so you didn't divide out or lose a root. And then you wanted to look to extract square roots when you had a squared term and a constant term. So today we're going to focus on how to factor an expression when you have a trinomial. So three different terms, 1, 2, 3. Specifically when your a value or your leading coefficient is 1. When we think about our quadratics, we can write it as a squared plus bx plus c. So we're going to focus when we have a leading coefficient of 1 for how to factor the expressions. Please note that it'll be the same when you need to solve an equation with your leading coefficient of 1, except the first thing you want to do is make sure your equation is set equal to 0. Okay? Then you're going to look for a greatest common factor, always a good first step. Then you're going to ask yourself what multiplies to c and adds to b. So what makes this number by multiplying and this number by adding? Set up your two groups and factor. Alright, so factoring an expression, we're unfoiling or unmultiplying. First thing you want to do is look for a greatest common factor. There is no greatest common factor between these three terms. Okay, we are just factoring. We're not set equal to 0, so don't write in equals 0. There would be an equal sign if we wanted you to solve it. What we are going to do is we are looking for things that multiply to 12 and add to 7. So ways to get to 12, 1 and 12, 2 and 6, 3 and 4. Out of those options, it's the 3 and the 4 that are going to multiply back. That should be a 4. Another way to think about that is, you know, this is a positive sign, so they're either going to be two negative numbers or two positive numbers. But then the fact that you're adding to a positive means that you would want two positive numbers here. That's your final answer, because you're not solving, you're just factoring. Alright, this next one, again, we have a trinomial. First thing you want to do is look for a greatest common factor. Well, all of these terms have a 2 in common. So I'm going to factor out a 2. Now that 2 is just going to carry with me as I factor. It doesn't drop away, but it definitely stays with us. I am looking now for things that multiply to positive 1 and add to negative 2. Well, we know we're multiplying to a positive and adding to a negative, so we're going to have x minus and x minus. The only ways to get to positive 1 are going to be with 1 and 1, or in this case, negative 1 and negative 1. If you quick check FOIL back, everything works out to get right back where you were. This one has one last step, because x minus 1 times itself could be written as x minus 1 squared. Okay. Again, you're not solving, so you don't have to set it equal to 0 and use your zero product property. You stop there because all it's asking you to do is factor. This time, it says to solve by factoring, so we're going to actually end up with answers x equals. Alright, so first thing is to get your equation set equal to 0. Then follow our order from before. So, greatest common factor, there isn't one. In which case, we are going to set up x and x, look for things that multiply to 12 and add to 7. We did this one earlier. Now, because we are solving, we have two things being multiplied to 0, which means either the first one is 0 or the second one is 0. Remember, this only works because we're multiplying to 0. So that means that x is equal to negative 3, or x is equal to negative 4. Solved it all out. Alright, next one. First thing, get it set equal to 0, which it is. Then look for that greatest common factor. All of these terms have a 3 in common. I'm going to factor out that 3. The 3 carries with me, it doesn't drop away. And now I'm going to be looking for things that multiply to negative 15 and add to positive 2. Well, because we're multiplying to a negative, I know that it's going to be one thing that's positive and one thing that's negative. So ways to get to 15 would be 1 and 15 or 3 and 5. 3 and 5 will get me to 2 somehow. And because I want it to be a positive 2, I want the 5 to keep the positive and the 3 to take the negative, because that way when you FOIL back, you end up with a positive 2x in the middle. Now we have three things being multiplied together that make 0, which means either the first one is 0, the second one is 0, or the third one is 0. Will 3 ever be equal to 0? No, so we can cross it off. What makes this equal to 0? That's when x is equal to 3. What makes this equal to 0? That's when x is equal to -5. So those are your two answers. Alright, this next one, I want you to go ahead and try on your own. Remember your steps. Get everything set equal to 0. Factor out a greatest common factor, and then look for things that multiply to C and add to B. Go ahead and pause your video now to try on your own. Alright, hopefully you got to this step right here. I set everything equal to 0, took out my greatest common factor of a 2x, then looked for things that multiplied to +8 but added to -6. So I came up with -4 and -2. So now that final step, because we are solving, there was an equal sign to start. I have three things that are being multiplied together that equal 0, which means either the first one is 0, the second one is 0, or the third one is 0. In this case, 2x being equal to 0 means that x would have had to be equal to 0. This one would be x equals 4, and this one is x equals 2. So we have three solutions to this one. Started with x to the third, so that is a logical conclusion. Please note the difference between the last example, when I had a 2 equal to 0, or sorry, a 3 equal to 0, and I canceled it out. That's because 3 won't ever be 0. But in this case up here, we're saying 2 times something equals 0. Divide both sides by 2. X is equal to 0 over 2, which means x is 0. That's it, factoring with a leading coefficient of 1.